Hi, everybody. Okay, so for this lecture, we're going to cover Chapter 3. This should be a review of what you learned in 3510, but it does serve to as kind of like the foundation for whatever we're going to talk about for the rest of the semester. So we're going to go over the basics of Chapter 3 again. So Chapter 3 covered 3 claims and 4 validities, which is essentially how we interrogate research. So for every research question, you will need to follow these general steps in the research process. We have the research question, the research design, then we find our answers using our statistics, we analyze them, and then we share in the published findings. And so we're going to assume at this point that you understand how to form research questions, and we're going to spend pretty much the majority of the semester talking about research design. Specifically, we're going to talk about selecting the design based on your research goal, right? Whether it's non-experimental, quasi-experimental, or experimental. We'll talk about these two later on in the semester when we talk about chapter 10, 11, and 12. You already talked about non-experimental designs in 3510. This is frequency claims and association claims, essentially correlational designs or descriptive research. We're going to determine our measures and recruit our participants using different sampling methods, which you've already talked about as well. And we essentially spend the entire semester, the majority of the semester, just on this one step. Now, students often come to me and they say, just teach me the design that's the best one, and I'll learn it. Whatever the best thing is, I'll do that. And unfortunately, there's no such thing. There's no such thing as one design that is the best one. We have different designs for different goals or different types of questions. So the first thing you should do is choose what kind of design you have. So the 3 types of general designs, as mentioned, are non-experimental designs, quasi-experimental, and experimental. And these really map on very well to our 3 types of claims. So non-experimental design is essentially asking or making frequency claims or association claims, and quasi-experimental or experimental are causal claims. So the research question that you have essentially guides the design that you're going to need to focus on and work on. And so questions such as what, who, how much, and how often are typically answered using these non-experimental designs. For example, what happens to your productivity when the room is colder? How often do college students skip class in the middle of the semester versus the beginning of the semester? Right? So these kinds of questions typically use methods such as interviews, observations, or surveys, and are either frequency claims or association claims. So frequency claims are essentially there to describe a particular rate or frequency, how frequent a behavior occurs, or the degree of which a behavior occurs in your environment. And so this is always measuring a single variable. So frequency claims only involve one measured variable. Alternatively, this type of non-experimental design can also be an association claim. An association claim argues that one level of a variable impacts or is associated or is related to this other variable. And so when you have an association claim, you have 2 measured variables, and these variables are typically correlated. Now, it's important to understand that there's a distinction between measured variables and manipulated variables. For both frequency claim and association claim, we are only talking about measured variables. These are observed or recorded in some way, such as height, weight, IQ. And in an experiment, this is usually our dependent variable, the thing that you're measuring, right? The outcome. This is in contrast to a manipulated variable. A manipulated variable only exists in experimental claims, not only, but typically exists in experimental claims. And this is where the researcher somehow controls or modifies or manipulates a variable to see its effect on something else. So let's talk about frequency claims. So an example of a frequency claim is 70% of Atlanta residents use public transportation regularly, right? So it's a percentage, it's a rate, it's a proportion of. And again, all you're doing is focusing on one measured variable and describing essentially how often it occurs or how common it is. So more examples are 1 in 30 people use an old school flip phone. 2/3 of psych majors are women. 52% of Americans are college graduates. By the way, I made all these up. I have no idea if they're true. But the 1 in 30 is the rate, right? 2/3 is the rate. 52% is the rate. And so, or the percentage. And so it gives you information about your population, and nothing is manipulated. You're just measuring that one variable. In this case, the variable that you're measuring is how many people have this old school flip phone. In this case, you're measuring how many people that are psych majors identify as women. In this case, you're measuring how many people in America graduated from college. Okay, so those are your variables. Association claim takes two variables and sees how they relate. So for example, shy people tend to read facial expressions better. So they focus on these two measured variables. The two variables here are shyness, or the amount of shyness, and the ability to read facial expressions. And so what you're saying here is that variable A is related or correlated with variable B, essentially that they predict each other. Now, we typically use correlations for association claims. There are other methods, other statistical methods to see how the relationship occurs, but for the purpose of this class, we're just going to stick to correlations just because they're easy and you should have reviewed them in 3510. And these correlations vary on strength and direction. So you should remember that a correlation ranges from -1 to +1. And now the number here tells us one thing, and the symbol, whether it be negative or positive, the positive here is implied, tells us another. So the number tells us the strength of the association, the strength of the relationship, meaning the closer to 0, the weaker the association, and the closer to 1, whether it's positive or negative, the stronger the relationship. So if you have a correlation of 0.1, that is very close to 0, so the association is very weak. If you have a correlation of 0.9, that's very close to 1, and therefore this correlation is very strong. Now the symbol, whether it's a negative number or a positive number, is the direction of the association. And your direction can either be positive association, negative association, or 0 association. So the positive association essentially states that the variables move in the same direction. It doesn't mean positive in the way we use the word positive, like good. It just means that as one variable increases, so does the other. Or as one variable decreases, so does the other. They go in the same direction. So let's give an example. Maybe reading your textbook is associated with better exam grades. So the two variables are reading your textbook and better exam grades. And what this relationship shows is that it's a positive relationship, whereas the more you read your textbook, the better your grades are. The grades increase as well. And another example is less sleep before an exam is associated with lower exam grades. So the two variables here is sleep, or amount of sleep, and exam grades. And you find that they move in the same direction, but they both decrease. So less sleep lower exam grades, right? So less sleep is associated with lower exam grades. Alternatively, we have a negative association. A negative association just says that the variables move in the opposite direction. Doesn't mean negative as in bad. And so as one variable increases, the other decreases. So an example would be watching Netflix during class is associated with lower exam grades. So the more you watch Netflix, the lower your exam grades. You can also have a zero association. Zero association is essentially when the correlation is zero or really close to zero, like 0.1 or 0.15, right? So these are essentially tell us that your two variables have no relationship. They don't predict one another. They're not related to each other. For example, how many burgers you eat is not related to exam grades, FYI. Now, one caveat for a correlation that is really common, and you probably have heard this a million times, is that correlation does not equal causation. Just because two variables are related to each other does not mean that one variable causes the other. But it's really easy to think that, especially, for example, in things that make sense, like reading your textbook is associated with better exam grades. So you might be thinking, well, reading my textbook will make my exam grades higher. But that's not necessarily the case. A relationship does not mean that they have some sort of causality. They could have causality, but it doesn't necessarily mean that. So, for example, you could have what we call a third variable. What third variables might be related to reading the textbook and exam grades that could cause your exam grades to go up? What about going to class, taking notes during class, studying from your notes, sleeping the night before, not getting drunk the night before? All of these variables could also be related or cause your grades to increase, right? So we can't say that reading your textbook causes your grades to increase. We can just say from this correlation, from this number, that reading your textbook is related to an increase in exam grades. So there's the relationship is also bidirectional. So if you can say a correlation when you have two variables, so you have the reading textbook is associated with higher exam grades, and higher exam grades is associated with reading textbook, your textbook, right? But you wouldn't say getting a higher grade causes you to have to read more in your textbook. That's weird, right? And so if you say it in that direction, saying that they cause each other no longer makes sense. And so if you remember nothing from this lecture, I hope you remember more than this, but correlation does not equal causation. Okay, so let's give another example. Let's say research found that as ice cream sales increase, so did crime rate. Does this mean that selling ice cream causes people to commit crimes? Absolutely not. Right? What is a potential third variable that could explain this relationship better than ice cream sales? What could cause an increase in crime rate or explain the relationship between ice cream and crime? Temperature. Essentially, summer and high temperatures causes both ice cream sales to increase and crime rate to increase. Okay. Now, if you have questions, research questions that are why questions or how questions, these are typically answered by experimental or quasi-experimental designs. Experimental means that you can manipulate all of your independent variables. Quasi-experimental, as we'll discuss later, means that you have one independent variable that you cannot manipulate, such as gender or age, right? If I group you in age groups like young and old, for example, let's say young being under the age of 60 and old being over the age of 60, I can't manipulate that. I can only assign you to one of these categories. And so it's called a quasi or fake experimental design. So these kinds of questions look something like this. How does drinking influence memory encoding? Why does looking at cute babies increase caregiving? This is my research question for my research that I used to do is why is cute babies why are babies cute and why do we pay attention to them? Really, we shouldn't. I actually have a 7-month-old that has kept me up, hence all of this, has kept me up for the last 5 days because she's had a fever, she's been sick, she hasn't slept, and therefore I haven't slept, right? And yet I look at her and I'm like, oh my God, you're the cutest thing in the world. I love you. Where in reality, I'm like, why do I even care, right? And so these kinds of questions typically use experimental methods such as two-group, multi-group, repeated measures, factorial, and mixed design. We will talk about each of these kinds throughout the semester. So don't worry about what they mean right now. These are just the types of experimental designs that we are going to cover. And experimental and quasi-experimental designs answer causal questions, causal claims. Causal claims have questions that ask whether this one variable or these variables cause another variable to change or occur. Okay. And so usually you have a manipulated variable that you're seeing if that manipulation of that variable results in a change in a measured variable. So you have a manipulated variable, your independent variable, and you're seeing how that impacts your measured variable, what we call the dependent variable. So as I explained, in a true experiment, or just what we call experiment, we don't call it true experiments. We assume that when you say an experimental design, it is a true experiment. A researcher manipulates your independent variable and then randomly assigns participants to these different levels of the independent variable or these different conditions. And then we measure the dependent variable. And in a quasi-experimental design, this is when you can't manipulate one of your variables, which means you can't randomly assign people to these different variables. So, for example, let's say cancer diagnosis. I want to understand whether cancer diagnosis is related or impacts, not related, whether it impacts depression scores. So I want to see whether you have cancer or you don't have cancer and whether that has differences, significant differences in your depression rate. And so I can't take a group of people and say, hey, you have cancer, you don't have cancer, right? That's unethical. I can't give people cancer just to answer this question. So I can't randomly assign them. I can't manipulate this variable. All I can do is separate people on this variable and assign them like, well, you have cancer, so you're going to be part of the cancer diagnosis group. You don't have cancer, so you're going to be part of the non-cancer diagnosis group. And then I can essentially look at differences in our dependent variable, depression rates, to see if there's a difference between them. Okay, so let's practice. So essentially, I'm going to read these claims, and you're going to say whether they are frequency claims, association claims, or causal claims. Now, I know that you're home and we're not in class, and so you can just not do this, and I wouldn't know. But there's no point in listening to this unless you're going to participate, right? This is to test you. And if you get these wrong, then maybe rereading this chapter is particularly important for you. So use this as a little mini diagnostic, that kind of like a mini quiz, but if you fail it, it doesn't penalize you. Okay? So feel free to write down these answers before I reveal it. You can pause this video or say it out loud just to test yourself. But if you get it wrong, I highly recommend that you reread this chapter, maybe listen to this lecture until you feel comfortable. And if you have any questions, you know where to find us. Okay, first one. 30% of seniors have dementia. And then this would be a frequency claim, right? 30% is the frequency, and the one variable that is measured is rate of dementia. Next is breastfeeding is linked to children's IQ. And this would be a association claim. So breastfeeding is our one variable, and IQ is another variable, both of which are measured, right? So rate of breastfeeding and IQ level or IQ score. Third one, cursing is related to higher intelligence. This is actually not one that I made up. This is a real one that recently came out, and I curse a lot, as you will find out in these lectures. And so, I was happy to see this relationship. And so cursing is related to higher intelligence. What would you say it is? It's an association claim, right? Related is the key word here. It doesn't cause higher intelligence. Cursing doesn't make you more intelligent, because if I just sat here and said, fuck, my intelligence doesn't just go up, right? It's not a causal thing. However, there is a relationship. Cursing being one variable that we measured, and then intelligence, the other variable that we measured. Next is meditation results in lower cortisol levels. This is also a true claim. So what would you say it is? And it is a causal claim, right? Meditation results or causes or leads to lower cortisol levels. And there is lots of evidence that shows that groups that meditate versus groups that don't have lower cortisol levels, cortisol being a stress hormone. Next is people who smoke are at higher risk for depression. So what would you say that this is? An association claim. So people who smoke are at higher risk for depression, right? It doesn't mean that smoking causes depression. It's just that people that smoke may just happen to have a greater risk for depression, or maybe people that are depressed are more likely to smoke, right? It goes both ways. And last but not least, 1 out of 700 Americans don't know how to read. And this would be a frequency claim. 1 out of 700 being the frequency or the rate of how often Americans don't know how to read. Okay. Good job. Again, if you got these wrong, reread chapter 3 thoroughly and let me know if you have any questions. Okay, so now that we talked about the 3 claims, we're going to move on to how to interrogate these 3 claims using the 4 validities. And you may remember these 4 validities from 3510. They are construct validity, external validity, statistical validity, and internal validity. The first 3, construct, external, and statistical, are true for all 3 claims: frequency, association, and causal. And internal validity is specific to causal claims. So let's talk about each one of these individually. So if we're interrogating frequency claims, what do we mean by construct validity? Construct validity is how well did they, the researchers, measure that construct, that variable? How good was their variable operationally defined? So let's give an example of what that means. So you may remember the difference between a conceptual variable and an operational variable. So let's say we have a conceptual variable of well-being. I want to measure well-being. Well, how do I measure your well-being? Hey, how well-being are you? Are you well-being today? That would be a really terrible measure, right? What do we mean by well-being? And so we have to take this concept, which is like what I would clarify as it's like a cloud. It's just like this thing that isn't tangible. And we would have to operationalize it in order to make it more tangible. So maybe we'd use a 15-item scale that has been shown to be related to well-being. Maybe I'd measure how many smiles you have across a 2-hour period. And maybe I can make the argument and operationalize that smiling more means that your well-being is higher. Or maybe I'd have a physiological measure of your HPA axis activation. HPA axis, by the way, measures stress hormones. And so maybe if I say your activation is low, then your well-being is high, right? Because that is one way that I can measure well-being physiologically. And so this 15-item scale could be a self-report measure. This number of smiles might be observational. I can observe this the number of smiles that you have, and then HPA axis is physiological, right? Or I'm actually measuring a shift in your body. And so we often have conceptual variables, but in research, we have to take this conceptual variable and we have to operationalize it somehow. So, yeah. So conceptual variable, operationalize. So back to our interrogating frequency claims, when we're talking about construct validity, we're essentially asking how good was their variable operationally defined. So for example, if our frequency claim is 80% of college students have been depressed during the last year, we really want to understand how depressed or depression was measured. Did they just go up to students like, hey, are you depressed today? Yes or no? That's probably a really crappy way to operationalize depression. Or did they give them an actual scale, a depression scale that has been validated, right? And if that's the case, then construct validity is good, right? Then we have external validity. External validity is essentially how well does the sample from this study represent the population? Essentially, how generalizable was this finding? So if we're talking about 80% of college students have been depressed during the last year, were these college students sampled outside the counseling center? Were they sampled during finals week? Were they sampled at the beginning of the semester when stress is really high? Or, was it sampled throughout the semester and across multiple locations? Because if let's pretend that they were sampled just outside the counseling center, you might actually expect that those students that are answering this question might be more likely to be depressed because they are seeking help from the counseling center, right? That's where you measured their frequency of depression. And so external validity means that the sample is representative of the population and that it generalizes to other scenarios and other situations, other times, and usually is a function of sampling issues in terms of frequency claims. And then third, we have statistical validity. Statistical validity is essentially the extent to which the study's stats are appropriate, and therefore the conclusions are appropriate and accurate. When we're talking about frequency, what we're essentially talking about is margin of error. So you may have heard or seen something like 80% of college students plus or minus 5% are depressed in the last year. That plus or minus 5% is your margin of error. And so let's say if 80% is our frequency, a margin of error of plus or minus 5% states that the true percentage of depressed college students is actually between 75 to 85%. Our data, our sample shows 80%, but we should expect that the range is somewhere between 75 to 85%, given our margin of error. Okay, next is interrogating association claims. Same three validities: construct, external, and statistical. So construct validity is the same. You're just looking to see how well your measure was operationalized, except now you have two variables, right? So in a frequency claim, you only have one because you're only measuring one, But in an association claim, you have two variables that you're relating to each other. So now you just need to make sure that both of those variables are operationalized well. External validity is the same. How well does this generalize to other populations, contexts, times, places, samples? And so again, this is usually a function of sampling as well. And then we have statistical validity. Statistical validity in an association claim also looks at whether the statistical analyses are accurate, but we're also here now looking at our correlations, right? And when we're talking about correlations, we are talking about the strength and the significance, but we're also talking about potential errors. So strength, as a reminder that we just went over, can either be between -1 and +1, right? The closer to 1, the stronger the relationship. The closer to 0, the weaker the relationship. And plus or minus essentially means the direction of the relationship. There are two mistakes or errors. They're not actually mistakes. There are two errors that allow us to make a false conclusion or mistaken conclusions: type 1 and type 2 error. So type 1 error is when we find a false positive, when essentially you find a relationship that doesn't exist. So I always love this because it's really funny, but it's like telling a biological male, you're pregnant. Not possible, right? They don't have a uterus. And therefore, you're finding a relationship that isn't there. You're finding a false positive. So if you have sometimes you find a relationship, we find a correlation that says that two items are correlated, but it's a false positive. A type 2 error is a false negative. Or in this example, is telling a biological woman who's 8 months pregnant, you're not pregnant. It's when there's effect is there, but we were unable to find it, right? So this is common as well, where you find that there's no relationship, but the relationship is there. You just didn't find it for whatever reason, typically due to sampling issues as well. Now, type 1 error is worse, right? Type 1 error is worse because we're saying that there's an effect when there isn't one. Type 2 error occurs, but it's not so bad because eventually somebody will find this effect typically, right? And so we want to be very wary of our type 1 errors. And then finally, interrogating causal claims. There are three criterias for evaluating and meeting a causal claim. Covariance. Essentially, you need to have a relationship. You need to have a correlation for there to be an effect. So if you want to say that studying results causes increased grades, then that also means that first you have to find that studying is related to increased grades, that there's a relationship between them. If there's no correlation between them, then they cannot possibly cause one another. The second criteria is temporal precedence, which essentially means that the variable that you're manipulating, in this case study time, comes before the variable that you're measuring. So if I want to say studying causes an increase in grades, so I essentially split the class into two and I tell half the class, you study for 5 hours for 2 nights before the exam, and I split the other and I take the other group and I say, you don't study at all. Don't just show up to class, take notes during class, but do not study at all outside of class before an exam. So what I did was I manipulated my variable of study time, right? That manipulation of the variable has to come before I give you the exam. Because if I give you the exam first and then I manipulate whether you studied or not, that's weird, right? I can't make a claim about anything about studying and grades because I gave you the exam before I manipulated anything. So temporal precedence is really easy. You just need to find out and make sure that the manipulated variable, the thing that you're manipulating that you want to see if it has an effect, comes before the measured variable, before your dependent variable. And then third, we have internal validity, which essentially states that the manipulated variable should be the only thing that changes across your manipulation. So in my example of splitting up the class in two, and one class is the study group and the other class is the no study group, right? So I'm manipulating the variable of studying. Nothing else should change. Everybody should still show up to class. Everybody should still pay attention during class. Everybody should still take notes during class. The only thing that's different between them is whether they study for 5 hours for 2 nights before or whether they're told not to study at all. And then we can make the actual claim that studying causes an increase in grades. Now, in terms of our validities, for construct validity in an experiment, the same thing. You just need to make sure that every independent variable and every dependent variable are operationalized well. Because now you have an independent variable, the thing that you're manipulating, and you have a dependent variable, both of which need to be operationalized. External validity essentially states how the results should be generalized to your overall population. We actually have a very particular problem in westernized cultures where we have very low external validity, which means that our results, because they're typically on college students between the ages of 18 to 25, and we typically do research with college students where they don't, it's part of their grade. We don't really have lots of data from people that are non-college aged or non-college educated. And so we have low external validity. We tend to test participants that are weird. Weird being an acronym for westernized, educated, industrialized, I forgot what the R is, and democratic. Not democratic meaning they're all Democrats, democratic meaning that they have free will and they have rights. So we actually have an issue in the field of psychology or in research in general in the US that we have actually low external validity. And then we have statistical validity. We're going to talk a little bit about the different stats, not a little, we're going to talk a lot about different stats throughout the semester. So we're going to talk about the different tests that we do and what they mean. But essentially, we have to make sure that we're running the correct stats and that the power of the study and the effect size of the study and the effect are high. We'll go over all of these in insane detail to the point where you might hate me by the end of the semester. Throughout the rest of the semester, we're going to talk about these. So don't worry if you don't remember them right now. And this table that's in your textbook is actually a really good guide for these different types of validities across the frequency claim, association claim, and causal claims. So we really want to also stress that when we're talking about all of this, most of you are not going to end up being producers of research. Very few students that are psych majors end up going to grad school to do research. You might go into counseling, you might go into some sort of occupational therapy. And so part of the goal of this class is for you to be a good consumer of research. And so one way to do that is to focus on wording when you're reading different claims. And so, for example, you might see this claim of early language skills reduce preschool tantrums. Now, this sounds like a causal claim, right? The word reduce is pretty definitive. Early language skills reduce, they cause a reduction in preschool tantrums. And so you might be like, okay, well, if early language skills reduces preschool tantrums, then I should teach my child to speak very early, and then they will have fewer tantrums, right? Very causal. And this is an actual headline. If you go to this link, you can read the study. But because we're online, I actually it's a very short research article, news article. And so I just took a screenshot for our purposes here. And so let's take a minute to read it. Verbalizing their frustration may help little ones cope is the subtitle for this headline. So take a minute to read. I'll be right here doing my little dance. Obviously, you should just pause this. I'm not going to wait for like 3 minutes. I'm just going to go on to the next slide, but unpause it when you're ready. Okay. So let's look at this claim and evaluate it using our validities for causal, not validities, our requirements for causal claim. So first, do we have covariance, right? Do they show in this that there's a relationship between the variables that they're discussing? Yes, they do show that there's a relationship. Good language skills is apparently related to reduced anger during this waiting task that they had in the experiment. Do they have temporal precedence? Meaning, did the variables that they manipulate come before the variables that they're measuring? Yes. They measured language skills at 18 months, and then they measured the tantrums at 4 years, right? So language skills, the thing that they're manipulating, was measured at 18 months. And the preschool tantrums was measured later at 4 years. So they do have temporal precedence. What about internal validity? So did they make sure that the only thing that's different between the groups was the thing that they're manipulating? And if you read this article write-up, the answer is no. They didn't actually manipulate a variable at all. All they did was measure language skills, and then they measured frequency of tantrums. That by definition, when you have two measured variables, what type of claim should this be? Your answer should be an association claim. When you have one measured variable, it's a frequency claim. When you have two measured variables, it's association claim. When you have one manipulated and one measured, you have internal validity, or the potential for internal validity, and you have a causal claims. So this headline is really misleading. It would be more accurate to state early language skills are related to reduce preschool tantrums. And they did find that children that had language skills early on were more likely to have fewer preschool tantrums, but they didn't control or rule out any other possible alternative explanations. And so therefore, we can't make the claim that early language skills causes or for sure reduces preschool tantrums. Okay. So this is just an example of how when we see headlines in the news or in our media, whether it be on our phones or computers, whatever, don't just read the headline, because the headline's goal is not to inform you. It's to get your attention so you can click on it. Because the only way the news agency makes money is by clicks, not by just people sharing. Okay. And there are very specific verbs used in these headlines that should tell you whether something is an association claim or a causal claim. So linked to, associated with, prefers, predicts, tied to are very association claim verbs. Causes, affects, leads to, adds, hurts, fights, prevents, reduces. These are all very definitive verbs that are more associated with causal claims. All right, and that's all I got for today. If you have any questions, please let me know.